Quite happy to be back here. It's a really cool meetup. I quite like it, very relaxed.
The best.
Yes, it is. This is the second part of my talk from last year. I couldn't get a chance to go through all the content, so happy to be back to go through the rest of it. Now, before I start, how many people have attended the September 2017 talk on this topic? 3 people? 4? And so out of those 4 people, how many people remember what I talked about?
Yeah.
1. Now the last question is, did you go back and fix some stuff?
We now use cores.
Yay! It's a good news to hear. So for the majority, my name is Pedram Hayati. I'm a security consultant and instructor. I teach development team how to write secure codes. Now, many things I talk in my trainings and also in Meetup here is based on the in-field experience, things that I see, things I pick up, and I'm more than happy to share them with you guys. Now, can you please also show a hand, how many of you are web developers working with web? All right, this talk is purely very good, relevant to you. If you remember from last time, those 4 of you, I started with the notion of patch burgers. And what I mean by that, when you want to apply a security, when you want to address a security issue, there are many ways you can go about it. You can fix the stuff in, can you please stand? You can fix the stuff in the code. You can fix the stuff at the web server layer. You can fix the stuff in the web application layer. There are many, many, many layers you can do about it. Now, if I want to make, If I want to make a mention of like web applications, top of my head, I can come up with 7, 8 layers, right? So there is no one way to fix a problem. Now, a question for you: which one of them is good? Number 6? not at all. We're gonna see that. Well, the reason I brought all these things up is go back to the same problem. Does anyone here like the burger without patties, without lettuce, without tomatoes, just burger with buns? How about the burger with just a lettuce and just a tomato? No, nobody, I would never buy that burger. And I would never even call that a burger. A similar story happens in security. When we're talking about security layers or different levels, we're always talking about defense in depth. So there is no single way to fix a lot of security problems. And a security has no flavor if we just only use a single layer, one of these, to address it. Now, out of those many layers, today's talk, we're going to talk about client security controls. There are many client security controls, things specifically for our case. In browser, we have browser sandbox, browser sandboxing. And out of many, we also have things called HTTP security headers. These are specifically those security headers that can help us to add additional layer, a security layer, on top of the vulnerabilities that we want to fix. At the time when I was preparing this talk, these were 9 HTTP security headers that were relevant to the security. Now, how many of you do number 6? Content security was very good. Just 1? I will talk about one of them, the first one, HTTP strict transport security, then I will move on there. So we pretty much covered the first 5. The first 4, I left the 6th one, which I'm going to come back to, and we did talk about course. Now, HSCS, does anyone know what this one is? It's the easiest of all. It's pretty easy. It's defined in RFC 6797. Now we're going to go to the RFC and read it through. No? It's effectively instruct a user agent, our case a browser, to only use HTTPS. It's declared by a strict transport security, and there's a number of directives related to that. You can define how long you want your browser follow this directive. For example, if I want a website only served through HTTPS, I will declare that when the browser sees this header, next time when the user visits that website, the browser will make sure that that website is served through HTTPS. All right? But there is a caveat here, not in all cases. In most of these HTTP security headers, there is a concept called Tofu. Does anyone remember what was this? Tofu is simply trust on first use. I misspelled the O at the end, that should be you. Now, what does that mean? That means if our user visited, imagine on my website, I want to serve everything over HTTPS. I want to make sure the browser serve everything, gets everything over 443 port. If first time a user visits the website over port 80 or an invalid certificate, that header will be ignored. And there is a reason for that. This is a text I got from MDN, the Mozilla Developer Network. Just because the initial connection of the user to our website is through an insecure channel, the browser will not trust any of those security headers. So that's why we need to make sure that anytime we want to serve HSTS header back to the user, we want to make sure that that happens through HTTPS and our certificate is valid. So any self-signed certificate will be ignored and many others. So I talked about it last time. I showed a demo of it, that how actually this doesn't work when you are only using HTTP connection to set this. When it comes to the HSTS, my recommendation is start putting HTTPS in your applications. You can define it at the Node.js layer. You can define it in your code. Start with a maximum age of something really short, maybe a month or something. Roll the application out. If everything works, everything is fine, because you don't want to lock out everything. If you have a certificate problem, you don't want all the browsers now in the world are just trying to visit your website through SSL. And then once everything is working, include subdomain. That means all the subdomain of your website also need to be through HTTPS. That's only instruction to the browser. And if you want, you can add your website, your domain name, to a list known as preload. There's a website called hstspreload.org. You need to go there and register your domain there. And that means any browser that shipped out, from next version of the browser shipped out, they will have your domain by default listed there as the domain name that has to be served, has to be routed only through HTTPS. Make sense? This one was easy, one was easiest to go through. Now I want to move to my favorite header, which is known as Content Security Policy. The story of this CSP is very, very interesting. In a security community, everyone here knows about cross-site scripting. Those alert one pop-up boxes sometimes you get in the penetration testing reports. What those are, these are pretty much proof of concept that there is a cross-site scripting vulnerabilities. Do I need to say what the exercise is? Everyone knows about it? Yes? All right. In security community, we lost the hope that we can fix XSS, because there are just so many cases that it's just not possible, not that easy to make sure all the inputs that come from the user are nicely sanitized and escaped. Hence, what we try to do, there was a suggestion come through like, all right, let's assume there is a cross-site scripting in this website, what we can do to mitigate it, mitigate the harmfulness. And content security policy came around. This is not the first time we're doing this. There is a lot of other type of vulnerability classes that we will see. It's very often it's harder to address it directly, so we come up with a mitigation way to decrease the harm. Content security policy, or CSP, came around to prevent pretty much XSS. It declared by two directives known as Content Security Policy and Content Security Policy Report only. It has 3 versions, and obviously it needs require very, very careful tuning. If you look at the directives, there are so many directives for Content Security Policy, but out of many, these are the ones that I think is very important for us to know. traditionally, the way that how does the content security policy work? A website will define that, for example, I would like only to load resources, and resources are JavaScript, images, Flash files, whatever you applet, whatever you can imagine, based on the directive name. I want only allow resources that are coming from this specific name, like in our example, ajax.googleapis.com, or self. Self means the current origin, the current domain that I'm in. So once you have it there, once the browser sees this, and imagine there is a cross-site scripting issue in the website. If what the attackers try to do, they try to inject an additional script to the page, and that script may be pointing to attacker's website. So it can load a malicious JavaScript to the page. But because that script is loaded from a domain that is not part of your content security policy, the browser will not load that. So that's one of the nice ways to stop it. You can even go further, make your CSP very robust, and that is the second example. In the second example, you are restricting the CSP to protocol, domain, and the path. So in reality, what happens is, if you have the first CSP policy, things like source image / logo.png will load because it's referencing to your own origin. The second one, things like https website.com will not load because it's not whitelisted. In the second example of the CSP, which we are hard coding the path and the protocol, obviously that the exact same path will work, the browser will load it. But the second example, you are here, like I'm trying to load a JavaScript related to jQuery mobile, with a bit of typo there, but it's coming from exact same domain, but it's because it's not an exact same path, the browser will stop it. Very restrictive, very good in a security sense, but you can choose which one you want to use. The problem with the whitelisting approach is, theoretically that's pretty much we can define. In reality, what happens is, a lot of these JavaScript libraries, they actually go and load other libraries from different domains, or they define additional script on a page. And what happens is, once you define the CSP, tomorrow your application will just stop working. Because let's say you are using bootstrap.js, and underneath bootstrap.js, it goes and loads jQuery.js from a website.com. And because a website.com is not whitelisted on your CSP, pretty much that broke the application. You will see errors like that, refuse to load, blah, because it violates the content security policy within your browser. So the solution was you need to find out what your JavaScript's doing to your page. If they are going and loading additional resources, you also need to whitelist them. Now, if you think of it for a while, this could be a nightmare. Just to show you an example, like how at the moment the Twitter's CSP policy look like. I'm using a website called Csv Inspector. So you give this website the name for the domain that you want, and it goes and analyzes the content security policy. And this is at the moment the CSP policy just in header in Twitter. There's not even content of the page. Why they needed to do is because all those JavaScript libraries that they do, they're relying on these other domains. Or another example, if we look at GitHub, using the same website, it's a slightly smaller, but it's still, you can see you need to list quite a few things. Like for example, if you're using Google Analytics in your page, you need to define that there. If you have, you're using some of the S3 bucket in your page and you're doing some JavaScript calls, you need to define it there, and so forth. And normally the best way to find these domains that you need to whitelist is trial and error. Or wait for a user to complain. Maybe that works better. So, now a research study was done by a number of known guys in Google. They analyzed over 100 billion pages, and they analyzed, in 2006, and then analyzed the CSP policies. And they found out that over 95% of these whitelists are just broken. Either it doesn't work for the purpose that they are, or just wrongly defined. So the same guys who wrote this paper, they suggested a new way to fix this problem. And hence the idea of nonce and a strict dynamic came around. And this is in the latest version of the CSP version 3. Has anyone heard of this before? No? One? Have you used it?
No.
No.
It's very, very hard when you try to do third-party libraries.
Exactly. The idea is beautiful. So what do? Instead of listing all those domains that you want to whitelist, which can be a nightmare, you define what is known as a nonce. And nonce is a random number that you can generate, and you put it in the header. So you put something like nonce dash some random number. Anytime you want to load a script tag, image tag, whatever resource that you want, you need to make sure that you define a nonce attribute on that tag that has the exact same number that is on the header. Then you can go ahead and set the source to any location that you want. Once the browser wants to load it, it will check if this random number matches with the random number in the header. If so, it will load the resource. Now, from the attacker perspective, if an attacker managed to find an XSS vulnerability in a website and inject a script to the page, because attackers do not know that random number, the script will not load in the page. Okay, this fixed the whitelisting problem. The other problem it also fixed was this new directive called a strict dynamic. And this is to address those scenarios when I said a website that you whitelist need to load another script or another thing underneath. A strict dynamic, what it does, it gives the trust, well, it let that script that you load to load other script as well. But there are some conditions around it, not every type of a script. Like most likely if it is created using this create element method, it will let you to do that. Otherwise, it will block it. So in your website, if you have something like a script source any without nonce, CSP will stop it. It sounds great. This idea came around in 2016, and they rolled it out, and most recent version of the browsers are compatible with it. A problem solved. We don't have any XSS. That is the end of my talk. Thank you for your attention. Do you think that was real? Really? Yeah.
Is that compatible with IE 11?
No. And not Safari as well.
But couldn't I, as an attacker, just look at the script tag and steal the nonce, then inject my script with a nonce?
Depends. The course will not allow that, so you cannot read anything from the page to be able to do it. So you want to send a link to the user to click on it.
So if it doesn't work with IE 11, does that mean that the header is interpreted as not valid and it lets everything through, or
Yep.
it doesn't let anything through?
Yeah, so that was another thing I was going to say, that if a browser doesn't support it, and currently there are many browsers out there that they don't support it, you still need to have that whitelisting approach. And that's why when you go to things like Twitter, you will see this massive list. And you do not see even things like nonce anywhere here because of the compatibility reason. Now the problem is not just compatibility. So that's just also keep in mind. We need to make sure that CSP is compatible. The biggest problem is they can be bypassed. And I think this is fun part of this talk, which I'm gonna show you in real sense how an attacker can go after the policies like this, and they can bypass it. Do you guys like to see that? Don't try it at home, just for educational purposes, just to see these things work. So if you are using CSP with the whitelisting approach, it is bypassable by a technique known as JSON-P pivot or JSON-P bypass. JSON-P is effectively a technique to request and receive a data from a host without worrying about cross-domain origin, things like that. It was a technique, I think, before CORS that came around. Imagine I want to fetch a data from a website using AJAX, and then I can just do that. It turned out to be that any of those domains that I whitelist, like say API that, imagine like I have this policy like that, I have whitelisted things like only myself and Google API. If any of those scripts that Google hosts contains a JSON-P endpoint, an attacker will be able to use that to inject their own code. So if we have a JSON endpoint like this, like the user will send a request, target/callback equals to log, and this request will send to the googleapis.com and returns with things like that with the object, and calling that function that you have defined in the query, log. So far everything good. An attacker can change that, change that callback, and specify any function that it wants. Now, in a lot of XSS issues, you will see alert because that's like a proof of concept to show that I'm able to run a different method from what is specified. So that was one thing. Now, to show you that actually this works, I have a demo application here. Here. Now, in this demo application, I have, everyone familiar with the dev tools in Chrome, like debugging tools? It's quite good when you want to debug this stuff. All right, now last time I went through most part of this application. For this one, when I want to talk about the CSP stuff, there is a about page right there. Let me just zoom a little bit, not that one, this one. All right, when you click on about, the error, damn, and then you look at the console, you will see there is something was logged in the console. Apparently that error did a call. Let's just do an investigation of what really happened here. So if you look at the query bar, you can see the error attribute following with the error. Now I want to go further to this, find out what's really happening. I can see there is a call for this JSON-P callback equals to error. And I can see this function was returned when this call came back. I can put a breakpoint right here, refresh the page, and by the time the debugger stopped the execution, let's just step through this to see what is being called. Let's step through the function. I can see this file, cspwh.js is being called, and inside this, this attribute.lead is selected, and then there's some jQuery stuff happening. I will step out of that, and that will print the error logged in console there, and there's a console.res, and if I want to see what is the value of res, well, there's multiple ways. You can just see it here, or you can bring up the console and type res to see what is the value of the res, and that is pretty much what will be printed in the console. When this once it's executed, done. We can see it on the bottom. Oh, cool. So we have a JSON-P endpoint, and the variable to that was log. Now, if I look at the CSP policy for this page, you can move to Network tab, select, for example, one of the requests, and look at the content security policy right there. So it's very restrictive in a sense. The part that we are really to care about is this script source. It limits all the JavaScript to load it from either the current domain or this protocol, this domain, jQuery, again, this protocol, this domain, Bootstrap, and there's a bunch of other things which I will talk about it later. So very restrictive. Now, as an attacker, if I want to bypass it and inject my own JavaScript code, the first thing I will do is try to change this parameter to something like alert. Now, the nice way of doing it, let's just have error right there with some random parameter, and let's just nicely have semicolon, and then alert with 1. And now what I need at the end is I want to comment on the rest of the stuff that comes back from the server. I'll put two things like a comment right here. Now, if my alert box pops up, this means I can do whatever I want with this website. Let's see what happened. So again, look at the source, look at the callback, set a breakpoint here, refresh the page. Well, the call is here now. My application calls error, the same function that was defined on the page. I step through it, again, same thing, error being logged, and now the second part, it moved to the alert one, and the alert will pop up. And if you can see right here, the rest of the stuff nicely is green, which means it's a comment, so the browser will simply ignore it. Now this is cool. How do you think now I can do something else with this? So alert was fun. Can someone tell me now, how can I turn this to effectively, this could be a URL, the link I want to give to a user of this website, I want to redirect them to a phishing website which look like this website. How would I redirect a user? Right here. You can inject JavaScript code. Ideas? You can inject any method right here, and that method that you have will be nicely run by the browser. So I have some method here, and then I will create this link. I will send an email to someone. Hey, check this out. And when they click, what I want to happen instead of alert 1, I want them to be redirected to another page. Any suggestion?
Window.location.
Window.location. So let's try that. Window.location, then
.href and a URL
.href, that is also a good one to have. Then
equals your URL.
href equals to
HC.cf.
No.
not sydney.com, that's better. Window.location.href, not sydney. Will that work? Let's try. No, it didn't work. Why is that?
You need to URL it.
Window.location. Let's just get rid of the href. HTTP. Is that right? Does it look right? And let us comment the rest. Just copy this, put a breakpoint. I don't have a breakpoint this stage, but let's see. No, it didn't work. Hacking is not easy. Why do you think it doesn't work, this one here?
Because there's no access to.
Anytime it comes to identifying a security vulnerability, things are easy. You can point at every part of the code. I feel there is a cross-site scripting here. But if you want to go to the bath and prove it, which we call it exploitation, that becomes really, really hard part. Because there's just so many moving parts. Now, why do you think this one has a problem? Someone mentioned of URL encoding. But doesn't the browser does URL encoding by default? So if I change this to %22, will that work? Like 27. So %27, let's see. Oh, it worked. So I just needed to supply the URL encoded for the code. All right, that was cool. That was with the whitelisting. So first thing. But how about this other one? This very recent version of Nonce and strict policy. It turned out to be that if there is a DOM-based cross-site scripting on a website, this latest mitigation technique is also bypassable. I will talk about this a little bit in more detail. So cross-site scripting has so many flavors. The most common one that we are familiar with is what is known as the reflected cross-site scripting. So an attacker will supply a parameter with like a script alert 1 that will go to the server. The server backend application will take that whatever supplied to that parameter, put it on a page, and send it back to the user, and that will be served in a browser. This is the most common one. But these days, with a lot of JS frameworks that can do a lot of manipulation to the page, there are cases where the JS library will look at some part of the URL or some part of the page and read the content from there and create, for example, a script tag. And there's just so many examples of it. It's just really hard sometimes to to find all these places that the JS will look at. The very common cases is if you have a URL like such as this, like if you have something like http.com/example.com and hash, something like that, many JS libraries, they're actually looking for variables that are defined right after the hash song. And I mean, there are just many other places they do. Now coming back to this, DOM-based XSS is effectively a type of cross-site scripting that the request is always the vulnerability is within the JS library. If you can find a place that JS library will look, and if that data is from a user controllable value, instead of putting like a normal field, put like a script tag over there, it turned out to be that JS library will go and read it and display it. So imagine we have a content security policy such as this. It's very restrictive in a sense. It restricts object source, which means like there is no Flash object applet can be loaded on this page. A script is pretty much locked down to the script dynamic and a random nonce. Base URL is another way to stop what is known as a relative attack, so I'm not going to detail of it now. Connect source will specify the places where your AJAX call can send a call to, and that is only limited to the self, that means current origin. And frame ancestor, again, is a separate thing, but this is to stop an attack known as clickjacking or iframe injection. We have also a directive called report URI, which will report to you if there was a CSP violation, like if a user is doing some stuff, so you can know about those things. It's just more like a reporting thing. Now we have this, and we have this example page, which is purely written in JavaScript front end. What I'm doing on top, I'm loading a jQuery from that address that you can see. Right on the bottom, and I have a single tag on a page as a href anchor, and inside this I have multiple attributes. One of them is data text, and I have this very simple jQuery function, where what it does is, and you can see the nonce is there, because for this script to work, I need to have the nonce right there. What it does is, if your user clicks on this link or the button, it will go and read the content of data text attribute, takes that, and put it instead of this click me. So if a user clicks on that, what will happen is you will see a result like that. You clicked me, right? Coming from this data text side. Very simple example. Now, imagine that data text part is attacker or user controllable. So a user can supply a value from somewhere in a URL or I don't know, from a form, and that data goes right in the data text. If a user supplies something like this, instead of you click me, the JS code that we have will nicely take that out and bump it on a page, and that script will run. And the nice thing is, well, not really nice thing from the security perspective, that because these things are all nicely defined within this nonce random thing, that the CSP will not stop it because it thinks it's a part of the code that you are pushing. You want to see an example of that? Now, the same application that I have right here, let's get rid of this debugger thingy. Let's go back to our app. There's a contact page. If you click on a contact page, there is an error. Now, if you look on top on the URL, you will see the error message is actually coming from the query parameter. Like if I just change it to something else, it will change. This is like a surprise, right? But actually, there are a lot of apps out there that does the same thing. Now, just to show you that in this case, and let's look at the content security policy that is defined here. Look at the content security policy, which has the nonce value is random. And I'll also show you the source page of this code. Yep. Right on the top, what I want to show is this nonce value. So page source. You can see I have the nonce right here. Otherwise, this resource will not load. And also, I have a nonce value for another method that I'm using here. So I'm loading jQuery, I'm loading Bootstrap, and what I'm also defining right here is a selector for, it looks somewhere in a page, it looks for this tooltip thingy, and then it will just make a call to that. So what is it? If you are familiar with a Bootstrap, this is effectively a tooltip in a Bootstrap. If you go through the documentation, if you want to have a nice tooltip for some of your DOM objects, you can use that function. So, well, that is there. But currently on the page, there is nowhere that there is a tooltip, so it doesn't work. Now, the first thing I will try, okay, I managed to change the error message. Can I just do, for example, I don't know, a script here, right here? Will this work or not?
No.
No, it didn't work. Because of two reasons. One, the content security policy stops it. So effectively, what I'm writing here will come on a page. So on a page, the browser will say, okay, script alert 1, it doesn't have a nonce, I'm not gonna load it. But on top of that, the new browsers like Chrome, they have something called XSS Auditor. They also look for suspicious entries like obvious like that. And they're like, okay, I'm not gonna load it, no way. But obviously, there's a way around it. Now, to investigate that, the first thing we need to know is how we can define a tooltip. So I have this parameter error that whatever I supply, it will nicely come and show it on the page. So what if instead of a script tag, I put like h1 and then hi and then h2, like bye, what will happen? That will load. It's not a script tag, it's just, kind of HTML injection. I can go even further, like say href, like, I don't know, HTTP, notesydney.com, and then say, click here to win, and then, and this will come on a page, and if you use, oh yeah, what is this, and then click, and then go to the page. So, okay, I can do a lot of things, but the problem is, this doesn't really satisfy me. I need something that I really want to get some JavaScript code to get executed on a page. So to do that, the first thing I will try is, all right, this page is looking for a tooltip. How about I just copy one of these tooltip the samples from Bootstrap and just chuck it there, like things like that. Will that show up? Let's try it. I need to get rid of this hashtag here. And yeah, it did work. And if I just move here, I can see a nice tooltip. It did work because, from browser perspective, this tag is okay. It's just a bunch of HTML tag. It doesn't really have any scripts, nothing really dangerous. But behind the scene, what happens here is, if we look at the source, and I'm gonna do this quickly because I know you guys are tired. I'm also tired, and this stuff is crazy. I'm gonna set up a listener just to see what will happen behind the scene when this thing is being called. I just set up a breakpoint on, this is a mouse over event. So I just set a breakpoint here on mouse over. Anytime that was called, my debugger gonna kick in. So let's do that, and then go to the page again, and then let's hover over it. Bang, my debugger got the request right here. So I'm at this function. Anyway, if you want to step through it, you can go through it. This is jQuery being called, and then later on, it's gonna go to this Bootstrap thingy. If you look at the Bootstrap code, if you search for tooltip, there's a class here that is defining tooltip. Now, long story short, it will go and call. You need to actually step through it, find all these things out, or you can read the documentation. It will go and call this function, tooltip prototype.show. If I put a breakpoint here and continue, F8. Now my second breakpoint, well, this one was not called, but that effectively going to be called, which is here. And if I step through this, I can see one very interesting thing right here, that the value of the stuff that is showing on tooltip is coming from a variable which is inside tip Let me just move over it a little bit more. If I look at the type variable, so right in here, there's a jQuery and int, I know what is it. The first array of that is this HTML class, which will be injected on a page with this content, some tooltip text, which is coming from that data text that I have defined. All right, here is an interesting one. Now, what will happen if I change this title? Let's see if any of those mitigation can stop me. I'll just continue the head. Now over. F8. Didn't work. The reason is, so you can see it did present it. This is because of one nice feature that is available for tooltip. There is an option called HTML, which will read that data as HTML. And I didn't have it in my tooltip first time. Let's add that to there and see what's going to happen this time. So I need to define an attribute right here. Data HTML equals to true, according to that specification. And let's run it again. Hover over, F8, F8, and here we go. Hey, now they will say, oh yeah, you put a script tag over there. Okay, sure. Do you want me to encode it? Sure. I'll just make it super, super safe. So script, because I don't know what is the safe version of that. So that is like a super safe version of script tag. You just have it, copy, just dump it there. Hover, F8, F8, here we go. Oh yeah. So bypassable. Now the fun part. I want to get user now again to redirect it to notecd.com. What was the command? Like, was it windows.location? Window.location equals to, okay, let's just put %27. notecd.com, %27, with the semicolon. Well, let's see if that works. F8. Oh, hover. Perfect. Yeah. There we go. So, seems like CSP is not winning, unfortunately. So we managed to bypass it. And the good thing is there is still a merit to use CSP. Doesn't mean we should not use it, but just to be aware of what it can and it cannot do. And also just to be aware of that patch burger I mentioned at the beginning. We definitely need to have CSP, but we cannot just rely on CSP to stop cross-site scripting. This is a graph I got from a presentation done from a conference in Europe, which the guys were kind of summarized what I just said. Different types of CSP, how hard it is to implement. So if you can see, the nonce plus strict dynamic, the last one, is a lot easier to roll out, specifically in a larger scale. However, when it comes to the DOM-based XSS, it's bypassable. If you're not dealing with DOM, JS library, which is really hard these days, you don't really find application which doesn't really deal with the JS MVC frameworks. Just to be aware, you need to find a different way to stop the cross-site scripting. Here are a few tips. First, do not use CSP whitelisting approach. Just have it as a compatibility. Go with the nonce and strict dynamic as long as you can. The nonce value, this is another one, needs to be random at every request. So every page refresh needs to generate a new nonce. Do not create a nonce for a user session that is valid for like whole time frame. And there is another way you can define the CSP policy. One is through the header. There is also a meta tag in a HTML that you can define the CSP there. Go ahead and do it there as well. So it kind of reinforces it. And lastly, just be aware of it. Have different way to stop these tags. That was pretty much what I wanted to talk. If you want to do all these things in Node.js, we have a library called Helmet. I'll just quickly show it to you, which nicely you can use it to, for example, define a CSV. So here is a backend code for the application I was showing. I'm using the helmet content security policy right here, and I'm defining all the object source, script source, base, blah, 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 blah. Thank you very much. Questions, or I get out of here? Questions?
I noticed in the HTML, like in the rendered page, the nonce didn't have a value in the inspector. Is that
Yeah, inspector doesn't show it, but in the view source you will see it.
right? So in the view source, that's the response received from the server. Right?
Yes, yeah.
Is the nonce actually removed from the page before it gets rendered?
Yeah, good one. That is a new thing in Chrome to stop a certain type of attack where, as you mentioned, that you can go and read the nonce. What they do, once the nonce is read, they just overwrite it often. So to stop that type of attack.
So if I query from JavaScript and query all script tags and search for nouns, will they show up?
As an attacker or as a...
As an attacker.
Look, you are...
If I do document.query selector all,
Yeah.
map over all the script and look for nouns, and then I just take the nouns, use that, and add my...
You're talking about an AJAX call that goes and read the content from a page and do the analysis, right?
No, if I inject the code on the page, then I can read it on.
You can read it up.
And then I can query for script tags, look for the nouns,
Yep.
get it, and then inject my script tags.
You can inject it, but you cannot read the nonce because it overwrites. The browser will overwrite it with just of this new technique. Yep. Yep.
Is the best way to protect from third-party libraries having vulnerabilities using a third-party tool? I can't remember the names of them, but there are several of them. The services that basically scan the libraries for vulnerabilities. Is that the best way?
Look, when it comes to the scanning tool, like there's two category of them: static code analysis and runtime code analysis. Often the tools do both. The degree that they go and identify the bug is limited. Like some of these bugs that I just explained is even hard for humans nowadays to find it, let alone you automate a tool to do it. But I don't want to say do not use a tool. Definitely use a tool. They do a scanning. They pick up a lot of low-hanging fruit type bugs and all the OWASP top 10 stuff. They can pick them up. But when it comes to things like really logic, like the tool will not really understand here that, hey, there was a JavaScript code for tooltip right at the bottom of the page, and if someone inject a tooltip, will invoke that. It's really like you need to go and read the page, understand it, and think about what you want to do. And those are like the limitation where the tools hit. But definitely run it. If you have it in a pipeline, definitely do it. The whole idea of my training or these things that I'm doing is, these days we are reaching to daily releases, and waiting for the security guys to come in and talk about the bugs is just too late. So we need to get devs pretty much on board of all these concerns so they can write the code straight up from scratch securely. And if you guys are interested to know more, there are some references. Everything that I talk obviously has come from some of the topics here. That was all. Thank you very much.